Hello learner, how do you do? Welcome to Manifested Online Classes. My name is James Kenyani. We are going to proceed with our topic on area approximation. So today we are going to do further solutions on finding area using the trapezium rule. As they say, practice makes perfect. So further solutions of finding area using trapezium rule. So the non-objective is to give the learner varied experience on solving such question. So it is to give the learner varied experience on solving such questions. So without wasting time, we get down to an example. So the instructions are very clear there. Use trapezium rule to find the area bounded by a curve y is equals to x squared lines x is equals to 0, x is equals to 2, and the x-axis. Use for trapezia. Use for trapezia. So learner, in this question, we've had some experience of solving such questions. When you have 4 trapezia, it means you'll use 5 ordinates. If we have 3 trapezia, you'll use 5 ordinates. If you use 3 trapezia, you'll use 4 ordinates. So the ordinates are one more than the trapezia themselves. So let's go to that business. So what we are having, there's the curve, there are those 2 lines. So to give a good, you can get a sketch, a simple sketch of that by using a sketch. You can sketch there. We have they talked of the x-axis. There it is. That is the x-axis. And learner, line x is equals to 0 is actually the y-axis. Where x is 0, you talk of the y-axis. So without much of ado, this is the line x is equals to 0, or you can still talk of it as the y-axis. That is one of the lines. There is another line. Let not your sketch note be very simple. You can use a bigger, so that it's not so small. So you'll have 1, 0. So roughly, if I'm using that, I'll have 1, 2, 1, 2. So the other line, x is equals to 2, is actually here. That line is here, learner. That is the line x is equal to 2. We go to that question. They are talking of using what? Use 4 trapezia. So you realize there is 1 here and there is 2. So if I created a line here, I'll only have 2 trapezia. So what should I do? I should create an ordinate here. At 1, I should actually create another ordinate here and create another ordinate there, learner. So in the end, I'll be at a half, and this one will be 3/2. So after doing that, you'll plot points for, you shall plot points for the curve. Plot points for the curve. We need to plot points for the curve. I don't actually know how the curve goes, but I have to plot the points from values of x is equals to 0 up to values of x is equals to 2. Actually, when I get the value of y here, I would have got that ordinate. If I get the value of y here, I'll have got that ordinate. If I get the value of y here, I'll have got that ordinate. So let me go to that. So we have x, y. I start with 0. When the value of x is 0, when the value of x is 0, 0 squared is 0, so the value of y will be 0. I'll move to a half. When the value of x is a half, what will I get? A half squared, so it will be a quarter. So when the value of x is a half, the value of y will be a quarter. Is that correct, learner? Yes. So when the value of x is a half, it will be a half squared. This will be a quarter. I'll move to 1. When the value of x is 1, 1 squared gives 1. The value of y will be 1. I'll move to 3/2 because I'm interested in getting the ordinates, the 5 ordinates, which represent which bound there for trapezia. I'll move to 3/2 or 1.5. 3/2 squared, what do you get? 9/4. 9/4. I've got the values. In fact, I can get a trajectory of the curve, learner. So one of the points when x is 0, y is 0. When x is a half, y will be where? Y is actually a quarter. So the value, in fact, that acts as the first ordinate, is a quarter. When x is 1, y is 1. When x is 3/2, so I had not completed learner, we have to move to 2. When x is 2, the value of y will be 4. So you'll find that on dropping, 4 will be actually above. 4 will be somewhere here. You'll find 4 will just be somewhere there. So when x is 3/2, that is 9/4, which is 2.25. 2.25. So at 1 is 1. Here it will be 2.25. And when x is 2, this will rise to 4. So roughly my trajectory of the curve is that one, learner. Roughly my trajectory of the curve is that one. So the area in interest is this one. Is that correct? Yes. So I've got my 4 trapezium. I'll go to the area. Area will be equal to a half h, the width of that. A half h mid loose, a half h ends plus twice mid loose. Mid loose. So I'll take this to be y0 is 0, y1, y2, y3, and y4. So my ends, learner, are y0 and y4. My mid-loose learner are y1, y2, y3, y1, y2, y3, and y4. So I'll just come and substitute in that formula. My width, h is actually a half. The strip width is a half. So I'll just come and substitute the values I've got for the ordinates. So the ends are y0 and y4. So I'll just come, write a half. The width is a half times a half. The ends, we are talking of 0 and 4. 0 and 4. So we are talking of 0 plus 4. Then you move to twice. What are the mid-loose? The mid-loose are the values you actually got for this, this, and that. So that gives, the mid-loose are a quarter plus 1 plus 1 plus 9 over 4. So that is what you have, learner. Working outside, a half times a half is a quarter. A quarter plus, you remain with your 4, into plus a quarter into 4 plus twice. 4 is like 1 is like 4 over 4. So you write a quarter plus 1 is 4 over 4, and that remains 9 over 4, learner. 1 is like 4 over 4. So you'll come a quarter into 4 plus, we now add 1 plus 4 is 5. 5 plus 9 is 14. 14 over 4. So I can also come and put here 1. So what will I get? I'll come and have a quarter into, the least common factor there is 4. 4 divided by 1 is 4. 4 times 4, 16. 4 divided by 4 again, 4. 4 divided by 4, 1. 1 times 14, 14. So it still works to a quarter. A quarter times 30 over 4. A quarter times 30 over 4. Let's go back here. Here we had 4 over 1. There is something we've forgotten somewhere. Here we got 14 over 4. So we came 14 over 4, let's see. 4. 4 divided by 4, 4. 4 times 4, 16. So it's a quarter times 13 over 4. A quarter times 13 over 4. Let's just check our working again from here. So we had a half plus a half, a quarter. So we remain with the quarter outside. 4, 2 into, this is, we got 514 over 4. That is where we went a bit astray. So 2 times 14 is 28. So it will work to a quarter into 4 plus 28 over 4. So that's where we went wrong. So it will work to a quarter into, the LCM there is 4. 4 divided by 1 is 4. So this is 16 plus 28. So you'll get 16 plus 28 is 42. So it's 42 over 16. 42 over 16. 42 over 16. So 2 goes there. 21. 2 goes there. 21. 2 goes there. 8. So the answer will work to 2 for true. The answer works to 2 and 3 over 8 square units. So that is how we work out. So you check 2 times 14, we got 28. Here it was 4 over 1. So we moved and we come and get our answer. So it is 2 and 3 over 8. It is 2 and 3 over 8. So having worked out that, check how we get that. The question looks different from the first one we did. So we shall look at the questions in the assignment. So before you go very far, it's always good to check. This was supposed to be 44. 44. 44. So this will give 22. And this will give 6 over 8. Check that. So this will work to 2. It works to 2 and 3 over 4 square units. So it's always good to check your work. It will give 2 and 3/4. Let's look at the question for the assignment. So learner, check what we did, and there comes the assignment. Use trapezium rule to find or estimate the area of a region bounded by the x-axis and the indicated lines. In A, y is equal to x squared plus 2. That is the curve. The first line is x is minus 2 and x is 2. They are telling you use 9 ordinates. When you look 9 ordinates, it means you are having 8 trapezia. In the second one, the line for the curve is y is 6 over x. The first line bounding that region is x is equals to 2 and x is equals to 4. Use 5 ordinates. It means you are having 4 trapezia. So with that experience of going through that, it will be your time now to work out that, as the practice would make you more perfect. Thank you very much, Lana. Enjoy finding that area in that assignment. Let's meet in the next lesson.